This is issue number 50 and issue number 70 for the Kaiju Engine. The first problem that I wanted to solve was the rotation problem that we had where we couldn't rotate any of the models here. So I'm going to make a sample rot equals matrix.float. We'll do -45 and 45. And then I also want to bring the host camera out. So host.camera set or set position, bring it out to 2, that's fine. And now what we want to do is we want to rotate the model. So we want to do TSD rotate, and we're going to rotate on the y-axis by rots I. Yes, vec3. Is this? There we go. So when we run this, I'll bring this over to -1 and +1. When you run this, we're not going to get anything because the rotations are wrong. Now, I was messing around with this earlier and I realized that the AI generated the multiplication mat for, and I checked the first one, but I didn't check the second one. Sorry, multiply. I checked the first one, which is this one, but I didn't check the second one. And notice it has a bunch of numbers. So I'm pretty sure that's the problem. So I'm gonna make it consistent with this one. We're just gonna paste that in and get rid of all the commas. And then we can say m equals, and this should be x, y, and this is gonna be, let's just put 0, 0 in here. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And then these are going to be 1, 2, 3. Let's try that one out for size and see if we get our 2 rotated rectangles. Sweet. So there's our 2 rotated rectangles. And let's flop this to be, let's make them face each other. So there we go. Although that didn't seem, oh, we're rotating after we translate. I rotate before we translate. So I think that should fix whatever crazy scaling it was doing there. There we go. So now they're facing each other. If I scale them back, they should be, or if I rotate them back, they should be appropriately, stay the same size. Cool. I think this is the way I want them. So one of the things I want to do is, you'll notice that there's a couple of lines here for, this moved again. There's a couple of lines here for add instance and add drawing. And we also create a draw group here. So we're creating a draw group. Essentially what I want to do is I don't want to create a draw group. I want to make it so that I can just pass in a block of things that are related to this drawing, and then it goes in the background and does all this association to draw groups and all that. So I want it to be kind of, I want to reuse this add drawing, but we're going to have something like renderer.drawing, and we're going to have shader, mesh, textures, shader data, TSD, and transform. The transform is because this mesh could be associated to an entity which could be moving around. So we want to take the entity's transform and this transform and multiply them together to get our final transform. So when I do an add drawing, that means we shouldn't have this add instance. We shouldn't even create a group, and we shouldn't create these textures. So we've simplified it down to create the shader, create the mesh, get the textures, create the data that we're going to apply to this instance for the shader. We can do some transformations here, and then we're going to just add the drawing. And instead of modifying this model directly, because like I said, we're going to have to take in the consideration this transform and this model together. We're not going to be pumping this model straight through. So we need to make it so that we create a model. I'm just going to call it M. And we'll do m.rotate, m.translate, and then we can do tsd.setModel, which is that function we previously created. And that's how we want to set it up. So with that, I kind of want to focus on now this drawing and what it is. So we actually do have a rendering and then drawing. And we have this drawings. So now we can add a type drawing. And it's going to have a shader, it's going to have a mesh, it's going to have a texture array, it's going to have the shader data, it's going to be the draw instance. It's going to have the transform as well. Matrix.transform. Okay. So now we are changing this add drawing to take in a drawing, which means the match group is going to have to change. We'll pass in the drawing into that. So match group has to change to take in a drawing. And then we're going to I think that solves whatever complaint it had. And we're going to change this DG merge to DG add instance, and this will be drawing dot shader data, drawing dot shader data. And if we didn't find a group, we're going to have to create it. So since we're not passing in groups anymore, we have to make the new group here. And this second argument is going to be the size of the data found within this drawing. So I think we had a function and we removed it, but it's going to be drawing.shaderdata.size, and we'll set that up in a bit. Then we can say group.addInstance, add instance drawing shader data, group.textures is equal to the textures from the drawing, and then we're going to append the group to this. So that's pretty much all we need for this guy, and now we need to solve this size and a few other things. So let's go to shader data here. We need to add in a size, but I'm also going to add in a few other things because we need to be able to destroy entities, which means that the meshes that are associated to them need to be able to be destroyed as well. And then we need to be able to activate and deactivate drawings, because we may want to draw a mesh and then hide it, and we just want to make it a little simpler to do that. So I have a destroy function. I have is destroyed boolean, and I have activate. I have a deactivate, and then I have a is active bool. And then we're going to be able to set the model, but we now need to update model for when we have a transform, and we need to multiply against it. So we're going to need some booleans here. Destroyed is a bool, deactivated is a bool, and I'm doing deactivated and not is active because I don't want to have to set this boolean every time I construct a structure that embeds this structure into it. So since it's automatically going to be false, I'm going to use the negative there. And then I want to align, since I'm going to be going through and generating a bunch of these and packing them together, I do want to align it to 4 bytes. So I'm going to make this top section take up 4 bytes before we continue. And I'm going to add a transform matrix.transform here, and then an init model matrix.mat4. Now this is a lot of matrix data for every single one of these instances. There's 2 matrices in here, but we'll optimize that if the size becomes a problem. So I'm going to wrap up some of these other destroyed things real quick, or the other field. So we're going to do func s shader data base destroy, and that's going to set the destroy to true. And then we're going to have is destroyed, that you figured that out, activate, deactivate, figure those out, is activated, and then size. Now the size is not going to be the size of the model. So, and we're also going to let the size be implemented by all the children and force it to be implemented for them to be used, just so that it's the correct size. Now with that, the size should start at this model. So this model and below, also I'm going to change this to lowercase m because I don't want to change it outside. This should be the starting point for our data, and everything is below it, since this structure should be embedded at the beginning. So I'm going to say const shader data or shader database start, or shader base data start. I know this is inverted, but unsafe dot offset of shader database model, and that's where it's going to start from. Okay, so that means that we just need to do our update. Oh, and our set model. So we're not going to just take in a model and assign it to this model. This model is reserved for our multiplied version of our matrix. So instead, what we're going to do is we're going to say s.init model. So the initial model is going to be equal to the model that comes in, and if s.transform is equal to nil, then we're going to say s.model is equal to the model. So only if we don't have a transform do we set our model, and that's in the case that we need to we want to reduce the amount of multiplication that we're doing here. So we can add in our func update model, and this is going to be if s.transform is not equal to nil and s.transform is dirty, so it has changed, then we're going to set s.model equal to let's do s.model.multiply s.transform matrix s.initial model. So we take the initial model and we multiply it by the matrix of the transform. And another thing I was noticing is that we had like a data size, and this is not used anywhere. It's just kind of added and not really anything is happening with it. So I'm going to remove this field. We don't need the data size. We can just work out from this instance size here. So we don't need a total running data size. We already have that inside of our instance data. So we got rid of, we deleted this merge function as well, so we don't need it anymore. That was its only usage. And now I just want to address another issue while it's on my mind, because I'm looking at it right here. We are just making a linear line of pixels, and on lower end devices, say like, on iOS or anything like that, we can't make a texture larger than 2488. So our max texture size is like 2488 by 2048. So we want to kind of respect that texture size when we generate it. And later on, we can work out multiple textures whenever our instances are there's too many instances. But for now, we'll just keep it simple and do the one. Draw instance group text size int32 int32. This is just going to return to us what the texture size is. So low end devices have a max 2048 texture size. So pixel count is equal to this guy. We'll just cut it. That's how many pixels we need. So the width is going to be equal to the minimum of pixel count and 2048. Height is going to be equal to int32 1, And then for pixel count is greater than 2048, we'll just, what? No, we'll do height plus plus and pixel count minus equals 2048. If height is greater than 2048, which means that we've created a texture too large, we're going to say that's appropriate to do handle this case with multiple textures. Return width and height. Okay, seems about right. So down here where we're going to do this, we're going to put in the width and height so we can calculate, we've calculated that now so we can grab it. D.text size, and we can make this W, H, and throw this up here on this top line. Now the next thing I almost forgot, thank goodness I was down there. The activate and destroy, we need to check for when we're writing instances, which means we need to change our for loop here. We're going to do for I is equal to 0, I is less than the length of d.instances. I plus plus, that's going to be our loop. We can make instance equal to d instances, and instance dot update model, and then we can do if instance is destroyed. This is the instance. This is a draw instance array. Yep. So if it is destroyed, we're going to say d dot instances equals slices dot delete d dot instances I and I plus 1, and then I minus minus. Else, it's going to be else if instance dot is active. Then we are going to do this stuff. Now, of course, that means our arithmetic here is going to be off because we're doing I times this instance. So let's create an offset equal to uint pointer 0. And then we are going to add offset there. And then from to copy, and then offset plus equals a uint pointer d.instance size. Seems right to me. Cool. So now we just need to make sure that everything is still in working order. So let's jump back here and let's try to run rendering dot draw tsd for the shader data draw instance tsd. All right, so we need to set the size for this. So we put it here, func t triangle shader data size, and we'll return, or we will do a const size is equal to int unsafe dot size of triangle shader data, return size, but this has got to be minus the rendering shader base start, and the whole thing as an integer. There we go. And that should make this guy happy. So let's see to make sure that we're still running and we still have our two rotated rectangles here. Cool. The only other thing I wanted to do in this is probably a little bit of cleanup because I've been using VX and let's just show you I've been using these vector components for color components. So we'll do color component equals int, just duplicate these, color component, and then we'll make it C RGBA. That way we can use these when referring to colors and these when referring to our vectors. So even if we come over here and we do a search for the usages of this, we'll see color here, so we can come in here and change these to be our CRGBAs. Put those there, put those there. CR, oops, CR, CG, CV, and CA. There we go. So now we're using our color components, and the rest of these are fine. Cool. All right. I think with that, that's all I wanted to do here.